Hi, everyone. I'm JC Jones from Mozilla. I'm actually an alumni of GatorLug. You might remember me from such GatorLug meetings as PGP Key Signing Party 2005 and PGP Key Signing Party 2006, where I signed keys and did cacert.org notarizations for what that was worth. But today Martin asked me to come in and talk about my current project, which is Let's Encrypt, a new free certificate authority. I am actually an employee of Mozilla Corporation, officially working on Firefox, but I have been given the interesting opportunity to be one of Mozilla's staff members working on Let's Encrypt on behalf of the Internet Security Research Group. So Let's Encrypt is all about cryptography, and anytime we start dealing with cryptography, we need some acronym help because it gets complicated pretty quickly. So,
Can I interrupt you for 1 second, JC? I was going to tell
absolutely.
people if you have questions, we should probably hold them to the end just because of the stream, and then maybe we can do questions at the end instead of trying to interrupt you over the stream. Does that sound good?
Yeah, that's actually what I was planning. Good point. I have a just block at the end for
Cool.
questions, and if you, yeah, just write them down and we can go have fun. I'll do my best.
Okay, thanks. Cool. Then carry on. Thank you very much.
So SSL, you've probably all heard before, Secure Sockets Layer. It's the circa 1990s name of the security layer for TCP. After much wailing and gnashing of teeth in the 90s, SSL, the fourth iteration of SSL was renamed TLS, Transport Layer Security, which is theoretically what everything actually is, and is the more apt way to describe security for HTTPS on the internet. HTTPS is web stuff over TLS using a good dose of X509 certificates. X509 is one of those IETF fun bits that it's best to just ignore. And PKIs, well, a PKI is an infrastructure for distributing keys. One of the main components of a public key infrastructure is a certificate authority, which is what we're talking about today. So with that out of the way, TLS, Transport Layer Security. It's some people still wonder what the real importance of it is. I hear all the time that it's really only for banks, financial data, or if you're going to use TLS, you should only need to use it for login and password forms. Everything else, there's no real point. But the problem is that networks are inherently untrustworthy. We see that more and more as the various large-scale monitoring operations continue to unfold before our eyes. And even worse than perhaps the obvious monitoring operations, the less obvious ones from our internet service providers and people we don't expect to be looking at the network. And unfortunately, standard HTTP that we all know and love for all of our web pages is just straight up no defense and has no mechanism to keep anything bad from happening, not even simple checksums. So there's like sitejacking is one of these things. People used to call it session hijacking, but the more fancy name now is sitejacking. If you don't have encryption protecting your links, all of your data transmission to and from websites, people can just take your nice session cookies and use them themselves. Location tracking is not just keeping track of what websites you visit, but many browsers will more than happily transmit your GPS coordinates over HTTP if they're asked over an HTTP link. You see this on your cell phone sometimes when it's like, such and such website is asking for your location. If you don't have a lock icon and you say yes, well, that goes in the clear. Unless you're using Firefox, where you don't let that happen. Reader privacy, I mean, everyone's probably aware of what happens when you click a link and the advertisers all change to remind you of what you clicked on. All these things are things that are problems caused by bad guys being able to look at what it is you're doing online. And HTTP just, it lets this happen. So we're still using HTTP instead of HTTPS in a lot of places because of various hang-ups that people have with adopting cryptography. The ones that I continually hear are that bringing in strong crypto, bringing in TLS lowers the performance of the web page and the web server, that it gets in the way of load balancing, certificates, of course, they cost you money, and they're a real pain to work with. Performance, Moore's Law and increasingly sophisticated processor instructions have really done an enormous amount of legwork towards removing the performance hits on crypto in the last 5 years. At this point, it's basically negligible. Load balancing is really an issue, but it's mostly for 15 to 20-year-old hardware that's actually being decommissioned. So even over the last few years, I've stopped hearing very much about, I can't do TLS, I can't do HTTPS because of my load balancer. The last two, though, those have been a hard problem for the community for quite a while. Certificates do cost money. You go to GoDaddy, it's $20, right, for the cheapest one. Sure, you can go to StartCom and get one for $5, but still, for a lot of people, $5 is not worth it. And then even worse, there was a person who stood up at a IETF meeting about Let's Encrypt just about 3 weeks ago that said he's a 20-year sysadmin, like he cannot install a certificate in under an hour. And I can sympathize with that. Certificates are a real pain. But those last two, money and error-prone, painful installation, are exactly what Let's Encrypt is all about. So Let's Encrypt is started off as a collaboration among these companies. It really started with the Electronic Frontier Foundation, University of Michigan, and Mozilla, but we've since added the other three as partners. And the whole point of this is to be a fully automated certificate authority that replaces all of the error-prone, complex parts with, well, as one of my colleagues says, replace them all with a really small shell script. It's not quite a really small shell script. You can go look at the code, but that's probably because we're trying to do everything. I have no doubt that given a little while, someone will write a really small shell script to do this. But that third point is that we're going to be trusted in all the major web drivers from the get-go, like starting as soon as we start issuing the first cert in the summer. They will get the lock icon. And that's very unlike cacert.org that I mentioned earlier and other efforts to go build free, trustworthy certificate authorities. So what are we actually doing? We are doing domain validation and giving free certificates to any entity that can demonstrate control of a domain. So there's three types or three levels of validation that exist in the certificate authority hierarchy, or the generally speaking PKI hierarchy today. Domain validation is the lowest. Organization validation you hardly ever see, that's OV. EV is the green bar. Extended validation, that involves having to get someone to do investigation if the person or company really is who they say they are, and properly registered and all of that sort of thing. And those are OV and EV are just out of scope because they require humans to be in the loop. But domain validation Just figuring out domain control. That's just so ripe for automation that we said, let's just go with that one. And we can give people lock icons. To do this, to get that, to be trusted in the web browsers, we just have to be, or not just, but we have to be publicly trusted. We have to comply with a group called Web Trust that does audits for the certificate authority / browser forum and all of their requirements. So that's actually a very tremendous burden, one that cacert.org never actually completed. But we planned for that from the get-go. All of our software, server-side, client-side, is open source, as are our specifications. The primary spec is called Acne, and we have introduced it to the Internet Engineering Task Force. We had a birds of a feather meeting at the last IETF, and we expect it to be formed. Every certificate that is issued is going to be published publicly. This is something akin to Google's efforts at certificate transparency, but the point is that the community will be able to do audits of what we do, so that not only do you have Web Trust to say these people are obeying by the policies they said and the CA browser forum baseline requirements, but also individuals can go inspect us in a way that you can't with GoDaddy, you can't with Deutsche Telekom. And we'll be applying the browser root programs as soon as is possible. Each one is a little different, so that's a lot of fun. But they all take typically 1 to 2 years. So during the time that we are that we're going through the root programs, we're going to be operating with a cross-signature on our intermediate certificate authority from Dentrust, one of our partners who's already trusted in all major web browsers. So I mentioned the open spec. That's called Acne. And Acne, it stands for the Automated Certificate Management Environment. We expect that to go onto an RFC track, and things are looking good on that front. Acne is implemented on our certificate authority side by a lovely piece of software that we call Boulder, because, of course, we actually originally called it Anvil, but there was already an open source Anvil project, and we requested we change it. But just as a quick sort of run through about what the protocol generally does, to get started, it consists of the Let's Encrypt software, the Boulder software on the right-hand side of the screen, and the client software running on the web server, the user's web server, on the left-hand side of the screen. The web server, the client software says, hey, I'm a web server for example.com. And Let's Encrypt says, well, that sounds pretty good. Here's a list of several challenges. In this case, one to put a secret value on the domain, and one to demonstrate possession of a private key. The client software has to go satisfy the challenges, which is what's being sort of shown here. The CA, based on how the challenges go, how it looks at the results of the challenges, gets to decide whether or not the client has shown sufficient administrative control. The protocol has, like, I think right now, a half-dozen challenge types that it can issue, and it can issue them in various combinations and multiple tries, depending on how risky we look at a domain as being, or how strange the results might get. But assuming that the client and the server can come to an accord about the challenges, the certificate authority notes that this private key identifying the server a particular server has control over the resulting example.com. At that point, now you basically have an account saying, hey, one of the domains that you control is example.com. That could be one of 300 domains with an additional 10,000 subdomains. It's not a big deal. It's just a marker. And then once you have, once you own example.com, you can go request or renew or revoke certificates via further Acme commands whenever you like. The point of Acme is to make running a secured server convenient for once, so that if you want to add another subdomain, it's a single command. If you're worried about one of the domains, you can revoke it with a command. You don't need to worry about it going back and forth via email. This can all happen via automated means, eventually talk over things like SNMP if you're interested in that sort of thing. I expect the client will eventually get fairly sophisticated. But the whole point of it is to make server software convenient. We expect that people who administrate their own web servers will ultimately be doing something like these commands. Obviously, Sudo may not be the preferred mechanism for some, but I know that there's already actually a project out there that is building a client on GitHub that doesn't need Sudo, but then it can't magically reconfigure Nginx and Apache for you. So do as you like. So the future is that Acme we expect fully to become an RFC. And we're here, we have, with our team, already built it to interact or to control Apache. We nearly have Nginx support ready for everyone. And more interestingly, we've heard from the Apache, the IIS, the Nginx community about building modules into those server software. And perhaps even more interesting, we've heard from various application hosting platforms. One, of course, is Automatic, who's a partner that runs WordPress.com. And many others that you would recognize have all gotten in touch saying they're building Acme clients so that when you want a new cloud server someplace, you can get a free certificate just through their web management consoles. With the whole goal of being free and open and removing the last barriers that we've identified to bringing HTTPS to everything, and finally getting to a state where all the data that you care about on the internet can go back and forth in a fashion where your ISP can't go inject tracking headers without your knowing. People can't go do strange ad advertisements. You know, you can use the network the way you want to, but with the added benefit of cryptography, or through the added benefit of cryptography. So, I'm not the only person doing this. I am working directly on the project with a bunch of very esteemed people, like some of you. If you're interested, if you know the IETF community, you've probably seen some of these names, like Eric there being the author of the TLS specification, and J. Alex Haldeman being a fairly impressive figure up at University of Michigan. The team is very very interesting, and we're having a good time. So. The intent is to go live this summer. We expect to start a beta program, if you will, with some trusted partners in the coming months, with the goal of being 100% online before the end of Q2. So now is the time for challenges and responses, and I will do the best I can, with the unfortunate side that I am not one of the folks who actually works on the protocol as much. So I will do my best on protocol questions, but I can talk at length about general PKI and other things. So, and I'll try on protocol.
Sweet, thank you. guess if you have a question, maybe you mind coming up just so that JC can actually see you and hear you to answer it. And maybe I will start with, aren't you taking away money from all of the CA companies that do this, and contrarily, are you making EV certs really expensive and different?
So it's generally understood that most of the market has been moving toward EV certificates in the CA world. And with low-end DV certs, there's been a lot of price pressure to bring them down to low cost anyway. It was probably inevitable that someone would eventually make the price floor go to zero, since they should be a commodity. It's putting a random number and then doing some math and putting another number behind it, right? It's not that big of a deal, as long as it's done in a trustworthy fashion. I don't think we're really a threat to the CAs. We may be just changing the way they go about marketing their services. And I think since we have the only way we can maintain a status as a free certificate authority is if we automate everything. And we'll never be able to automate EV certs, for example. So at least not as they're currently defined by the CA browser forum. So I think we're just causing a bit of a market shift in the benefit of the rest, the public.
Other questions? Does anybody have a question? I can hand you the mic, or no.
Hey JC, thanks for doing this today. Do you know if any of the other CAs are potentially thinking about implementing the Acme protocol for their own purposes, like StartCom and some of the other smaller CAs that are already doing free certs?
So I've personally gotten emails, since I'm one of the few people with an actual let'sencrypt.org email address, from CAs that I shouldn't name here, that you would totally recognize, who are very interested. We've got a test implementation folder out in the wild that is being used by at least one other big CA that you've heard of. So until they announce something, I can't be the one to do that, or until they publicly announce something. But yes, I fully expect that Acme is going to get picked up by more than just us. And it's pretty clear as you go look at the IETF Acme mailing list that you can see representatives of many of the big CAs trying to make sure that it meets their needs too. As a note, there's nothing in the protocol for Acme, just as an amusing thing. There's nothing in the protocol for Acme that stops you from putting a payment mechanism in, right? That can just be another, we've explicitly talked about it, that can be another validation. It's just not one that validates the domain. It's more like, have you actually transferred the money? So I could totally see Acme in use for all certs everywhere, and that's the goal.
You mentioned that the word Anvil is already in use in a software context. I'm pretty sure Acme is also. I think that Acme software is like Jeff Puskanzer or some other very recognizable early Unix guy.
I believe that's true too. It seems that no one's quite as upset about us naming the specification Acme as they were about it being a software package. So typically IETF gets away with murder on this sort of thing. So as long as we stay under their auspices, it should be fine, I think.
I have one more, which is, so what you're doing is validating a domain, but I guess right now, I think, maybe I'm just wrong about this, but I thought CAs were doing other things, like root CAs were doing other things to validate aside from the domain. Like, do you anticipate this being used for someone completely anonymously, or like, does it need to be valid in your DNS for them to get a certificate, or like, is it just API driven? Somebody says, I registered whatever.com, give me a cert, and you don't know much about them, or maybe that's covered in how you get into the root CAs as part of the requirements. But I think it's an interesting point.
So domain validation says that you have verified that the client, that the subscriber for the CA browser formatting rules has administrative control over a domain. To do that, the typical means is that you, like GoDaddy, sends an email to one of the typical administrator at domain.com, right? Which, if you think about it, is kind of a terrible way to do this, since it's unencrypted and anybody can intercept an email, but that's the state of the art. So if somebody were to do a DNS hijack for the MX record, you take that, they could certainly go convince GoDaddy to misissue a DNS certificate. GoDaddy does some things like multi-path DNS checking, which Boulder will be doing as well.
Well, they'll all have that problem. That won't just be a problem with Let's Encrypt, of course. I was just more thinking, like, would you give a cert to somebody that didn't have a DNS entry? Like, if they just wanted to use it for, since your project is mostly about encryption and less about, like, the focus is everything should be encrypted, not necessarily everything should be validated. I didn't see up there. Like, it's not let's validate and encrypt, right? So it's like encryption is a good thing by itself, and self-signed key, certs with keys are a good way to encrypt something to somebody, even if you're not checking that they own some DNS entry somewhere.
So the certificates that come out of Boulder, out of Let's Encrypt in particular, give you not only encryption but also authentication. That the certificate, at the time it was issued, was given to someone who had administrative control over the domain. Which, again, is all you get out of the domain, the cheap certificates out of GoDaddy as well. Except that we do it through what I think is a technically superior mechanism than email. So it's still authentication. I don't remember what the beginning of your question was, though, but it's more than just encryption.
Okay, yeah, that's all I was getting at.
So I have a question. Is this really focusing more just on like HTTPS type transmission, or is this like because you're saying everything, so it's like email or FTP, any kind of protocols that can currently use SSL or TLS, more so TLS?
So the requirements, we're only building client software to help with web servers. Anything that does anything that uses TLS can use the certificates that come out of the Let's Encrypt client. The trick being that you have to obey the appropriate protocol pieces, right? So there's not going to be, at least from the get-go, a validator to make sure that your mail server speaks the correct. There's nothing to make mail servers do domain verification through subject name extensions, right? We're not building those sorts of pieces in it, but it's a relatively common question. Can I use this for my Jabber server? The answer is we're not going to stop you from the policy standpoint, and we're not going to stop you from, I mean, the certificate's just going to work, right? You just have to copy it. So I expect to see community, we're just not going to provide support for that today. The community's, I'm sure, going to be able to do more with our certificates that are perfectly fine as long as actually, they'll be perfectly fine, right? You have to demonstrate control over the domain. Then I don't care if you use it for your Quake server or if you want to use it for whatever else purposes.
Okay, so the main goal of it then is for web purposes, and then anything else is just not supported, but not necessarily wouldn't work.
The official client is starting with only web servers.
Okay, thanks.
I expect other clients to exist.
I'm back. Okay, so
Excellent.
a little bit more detail. Kind of a follow-up to what the question that was just asked. In a specific case, people are going to want S/MIME certificates, probably for digital signature. You can technically do that with the same certificate. You just need the right X503 or X503 509v3 extensions on the certificate for digital signature, but the distinguished name also matters in that case for verification. Are you guys going to support interesting distinguished names at first, or maybe later on down the road, or if I get the Acme client or get the protocol working, kind of do it on my own?
So the state of the art is to not use the common name for that sort of thing. You use the subject alternate name extension, and you can insert SANs for a variety of purposes. We're going to be whitelisting them to start with until we have a good way to validate the identity for all of them. For example, you can include a SAN for an IP address, but there's a whole lot of issues with validating IP addresses, primarily because of NAT, that sort of thing, and DHCP. So I'm not in a good point right now to say when we would allow non-DNS subject alternative name extensions. S/MIME has come up already several times on the Acne specification mailing list, and I don't think we're going to do anything until the Acne spec to support S/MIME, until or code signing certs for that matter, until the Acme working group, once it's formed, can come up with a way for us to do automated validation. Trust me, I want S/MIME certs too, but like domain validation, we figured out right off the bat. So
that would be awesome. Like just personal email certs for everyone. Like lower the cost of that to free too, and it would make a big difference on the same issues.
Yeah, that's one of the things that I still use my cacert.org credentials for, but since nobody uses that CA, it's kind of weird.
So I have two questions. The first one is, since you're adding alternate domain verification mechanisms, kind of an extension of Martin's thought, I think, is since you're adding alternate mechanisms, I know there's been attacks on the validation before by registering email addresses on email providers where they don't restrict certain email addresses, like you could register admin at, and then you could potentially get an SSL certificate. Is there a concern that by adding extra domain validation mechanisms that you might be opening up more holes?
Yes, and that's one of the main reasons why we wanted to get into the IETF process as early as possible. The minds that are available to think through these problems are probably best represent, or what am I exactly trying to say? Putting ourselves in front of the IETF to have those verification mechanisms worked through by the public is, to me, the best way we can go about getting a really wide variety of inputs as to attacks and mitigations. Like, I know that the one that we're thinking of as our flagship verification mechanism, BDSMI, using the subject name indicator extension in TLS to demonstrate administrative control of the web server. There's some attacks against that if you're really clever, and that we know of, right? So come up with some mitigations. They've been discussed in that list already, and I expect we're going to come up with more. I hope so, but that's why we want it to be an open process.
Okay. My second question is Facebook and blockchain.info got a lot of press because they got SSL certificates issued for their Onion domains for Tor. Is there any plan of supporting that in Let's Encrypt?
So we, yes, there's a lot of talk about that. One of our main, one of the groups that's founded the Let's Encrypt initiative is the Electronic Frontier Foundation, and they do quite a bit with Tor. In fact, the folks that I'm working with directly, most of them actually work like on both the Tor project and Let's Encrypt. So trust me, this gets a lot of interest, and we just have to go find the right way to do it.
Thank you.
Mm-hmm.
Can the certificates that one gets from Let's Encrypt be used to recursively sign children's certificates?
No.
I'm not sure if I'm using the right terminology.
They will not be given the extensions for being a CA. Our intermediates are going to have a path length of 0, meaning there cannot be additional intermediates underneath them. And any further intermediates that end up getting issued will happen off of the root. So we're a big fan of doing technically constrained intermediates. So no, we will not be issuing. There are no plans at present to issue intermediates to anyone else.
Hey, JC, when are you coming back to Gainesville?
It's a good question. I've got a pretty full travel schedule for the next 6 months.
The free culture group seems to have died out here in Gainesville since you left. Have you heard anything about those guys?
I haven't, and it's kind of sad. I've gone walking around in San Francisco with my freeculture.org shirt, and nobody quite knows what it's for. I caught some people at the Computer History Museum in Mountain View understanding it, but yeah,
not a big free culture movement going on there either.
Doesn't sound like it.
Okay.
There's been a lot of great work on that front, but I think you could sort of say that the free culture movement got a lot of its goals accomplished by making Creative Commons actually a valid license that a number of people know of. It shows up throughout the blogosphere.
Miss you here in Gainesville, and we haven't had a key signing in a long time, because we hadn't had anybody beating the drum hard enough, I guess. But we should do that. We should do that.
Well, keybase.io almost kind of replaces the concept, but you have to decide whether you like social warrants of possession.
Right.
Anybody else have any other questions? No? Cool. Well, thanks again for presenting to us and virtually coming here. And if you do make it down here, we'd love to have you at a meeting again. So thank you so much.
I should totally come back.
You should. You should. So cool. All right. Thanks. Thanks again.
My pleasure.